And welcome back to the Pi Data Track. I'm Kim Nguyen from 6 Feet Up, and at this moment, Justin Garrison from AWS, Senior Developer Advocate, will be giving his presentation on data lakes and streams with S3 and Lambda. So over to you, Justin. Thank you.
Yeah, thank you, Kim. So many of you might have some data usage at your company. There's lots of things that's, businesses need more data. They're adding more to these lakes over and over again. And I don't really care if it's a data lake. I don't care if it's a data warehouse. I don't care if it's a houseboat. I don't care if it's data Great Lakes. Whatever it is, you probably have some data and you want to make some decisions off of it, or at least format it so you can use it. Sometimes it's just applications, you need it in a web page. Sometimes it's long-running ETL jobs, whatever the case may be. Your company's collecting data because they're data-driven. Whether that's decisions making those, using the data for decision making, or using the data to drive up bills, whatever the case may be, you're data-driven, and you need to have this data so that you can theoretically make better choices about what you're doing at your company. There's lots of ways to get data. We can pull free data sets. You can produce it and collect every log from every system and every application and throw it in this, giant pool of that's where the data goes, and just say, okay, now we have big data. But really it's about making that data useful. So at some point you have to process data. You have to get that information from a lot of text, whether it's on disk or behind an API, whatever the case, and you need to be able to do something with it. So let's look at like a couple different ways that we've done it in the past, how people have been successful with it, and maybe how we can use it a little more effectively going forward. Let's just take an example of, I have transaction logs. I need to get these transaction logs from a sale we're doing, from some system that's producing this log. But obviously there might be some special PII information in there. We don't want that data to be accessible to everyone. So you're going to take that data and you're going to run it through some sort of scrubbing system. And you're going to say, okay, let's get this data out. Let's not expose that and store it in this format, because it's not good. Like, a lot of bad things can happen with that data if it's stored in a way that, has information that we don't want. So in a lot of cases, you can take it at the log level. We're producing this log somewhere. We have an agent that lives by the log, and we can scrub that data. There's tools like FluentBit or FluentD can do these filters. Datadog can filter out logs as they're coming out of being produced, and it can automatically match based on some patterns. Great. It never leaves the box. It never leaves the container, whatever the case may be. It never goes and is permanently stored and now is part of your data lake. That's a pretty good solution because we can pre-process some of that information. But sometimes they might be aggressive, and those situations we do want more enriched data, or we don't want to lose some of the metadata, because we actually, we need to do something else later on that says, okay, well, I actually need to combine 3 data sources. And you don't want to do that at the processing end, because that gets really intensive just to get the information out. And the more processing you do ahead of time, the more it's going to be delayed to actually get results. And so a lot of cases we might need data that's tracking how many sales per minute or per hour or something. And if you do a lot of processing up front, your per minute's going to lag behind. You actually all of a sudden shifted and you're looking at the past whenever your dashboard is like, hey, this is really cool, but actually that happened 20 minutes ago. And maybe that's not fast enough for some of your systems to make decisions. So pre-processing is good for smaller things, but maybe not for like combining a lot. Doing a lot of computational heavy work, combining information, those sorts of things might not work best at a pre-processing level. Then you can take really large data sets and you can run ETL jobs on them. You can put them in a system like AWS Glue, which you're going to send that data to an endpoint, and you're going to have crawlers that go through this data that are going to look at, okay, what's in here? How do I format this data? How do I make this data more easily searchable? Because in that case, you have, you know, hundreds of gigabytes, terabytes, maybe petabytes of information, and you actually need to get something usable out of it. And doing on the fly searches for that is going to take a while. If you're like, okay, well, let me let me pull up my command line and just stream that data down. It's like, oh, actually, if you're sending a terabyte of data over the wire, it turns out you're going to have a bad time. It's not going to work well. There are still physics involved in computers. I'm sorry to be the one to tell you, but that's how they work. It turns out those electrons on the wire can't move faster than the speed of light and aren't bigger than an electron. So the amount of data we can store and push around is limited. But these ETL jobs are super beneficial for those large data sets. And let's make parts of it either formatted different so that we can search it, or even change some of the data where we say, oh, well, let's actually take my transaction log stream and my inventory and combine that information into a single searchable endpoint. It's like, okay, that actually makes sense. I can store both of those things, both of those two lakes, whatever. I can combine them together and make a third lake, and now I can look at that information. I can search it more easily. I can process it, and I can get better information that's better for my business. Like it's more usable for my business at that point if it's in a format with information that I need. Once you start saying, okay, well, I have 30% over here and 10% over there, and the rest of it is scattered throughout all these different logs and places, being able to combine that into a single place to get that information quickly is a big goal. So getting that faster is great. But again, ETL jobs typically are long running. They happen maybe nightly, so you're not getting up-to-date information. How are you going to get this information in a more real-time fashion to say, okay, well, I want something that's part of the day. In a lot of cases, okay, well, let's run the ETL jobs twice. Fine. That's a valid solution depending on the use case, but maybe not. Again, like you're delaying your information. You're also storing multiple times. And in some cases, you're going to have data that's, one set that needs to be transformed into another set. And then you actually need to take that second piece and transform it again. And so you don't have all the enriched data until you get to the third stage. So now you're waiting, you're making these, job execution DAGs, these, this graph of, okay, I need that one, then that one, then that one. Okay, now I can run mine. Now I can store it again. And you're storing this data over and over and over again for these different formats, for these, different searchable endpoints. It's great if you can have that delay, if depending on how big the data is, depending on how long the jobs run, valid options, but maybe still not solving your problem. You want data quick. You want to be able to, and also like these ETL jobs, if they're having nightly dumps, you're running all of these jobs again, you're storing all that data again, and then you're searching it all again. And that's a lot of computational work. Granted, at nighttime, right? Like people, oh, we'll just put it at night, right? With the ETL job, right? Midnight comes around, that cron goes in, and all of your jobs cascade from, okay, well, I have this cron, literally like have done this where, okay, this cron fired first. Okay, the second one, like it should take about 2 hours to run that first one, right? But like once your data is too big, oh, now it took 2.5 hours. And so that second cron failed because you have to just like bump that sleep another 30 minutes every time. And what you actually want is when this is done, fire the next one. When this is done, fire the next one. Hey, maybe I can process 2 of these in parallel because I don't need to wait sequentially. So there's all these like complexities of job management on how you're doing this. And you could do it a lot of different ways, cron jobs. I've seen it done in Jenkins. AWS Glue has a lot of this functionality. Like there are ways to do this depending on your data sets, depending on what you're trying to get out of it. But downsides, again, it's going to be a little slower. It's going to be, there is a delay here. It's computational heavy. If it is, your petabytes of data is probably your option. That's probably the best way to at least get it to some format you can search, and then you could chop it up into smaller bits. There's lots of things we can do if we can store this information into smaller chunks of data. And we say, okay, well, this 10 petabytes of data, who knows what's in it? Let's chop that up into gigabyte chunks and index it and figure out, okay, how do we get to these little pieces? It's a little bit harder to then combine that back and say, oh, well, I could do it at the petabyte level, but I can't do it at the gigabyte level. I can't figure out how to get usable data out of this chopped up bits of what originally was the thing I thought I wanted. And that's where, for me, I've done a lot with, let's look at dumping this data into S3. We can index those objects in S3, and then we can pull some of that information out in smaller bits. Great. That allows me to like pull it out, but I need to like know how to search the index. I need to know which parts I need to pull in. I need to pull from another system. A lot of times I do that on my client, and that allows me to like, okay, I can have full flexibility of whatever I'm doing, but it's computational heavy. It might be even expensive depending on how much data I need to pull down. If I need, a gigabyte of data, but my chunks are 5 gigabytes of data, I can look at that, file and actually request like part of the file. Might work. Maybe it doesn't, depending on the index, depending on how you're getting that data. So at some point you do just want to pull down these files and then you process them locally. You might need to reformat them. You're going to do a bunch of for loops and pull out different pieces, and you're going to grab data from somewhere else. It's valid, but it's my laptop then chugs. It's like, I can't do that while I run a Zoom call. There's limitations to computing still. So a scenario that I wanted to look at was, let's say your company says, hey, we need you to help us look at some information we have about job postings in New York City, right? There's a public data set out there. We pulled it in and we dropped it in S3 for you. We have 3 other jobs that use this data. We want you to use it for this other endpoint. We need to get some more data out of it. Really what we want to do is we want to see what types of titles and job offerings there are in New York. Great. It's in S3 bucket already. It's already chopped up reasonably well, and you can go grab that data. Maybe they did scrubbing, maybe they didn't. Maybe there's some situation where you don't know what the data is, but let's go ahead and like dig in and look at it and say, okay, well, I can do something with this. So let's actually show what something like that might look like. All right. So all they gave you was, here's the AWS account, here's the S3 bucket. Go ahead, we need you to process that data. It's cool. I know Python. I can do this locally. No problem. I'll be able to just pull it down and do whatever I want, but I might need to use it, I don't know, 3 different times. And so I'm going to have to process this for a couple different applications for whatever the formatting is. So let's go ahead and look at the data. Okay, we have it for you. Go look at it. And it's called NYC jobs data. So we're just going to copy that down. Okay, we have an S3 bucket. We know the thing we want. I don't know how big it is, but this is what I was told to get. Let's go ahead and pipe that through less, just in case we want to look at it. Maybe it's going to come fast. Who knows? Oh no. Here's our biggest problem right here. They gave me XML data. Like, what am I going to do with, I have to now translate, like locally, I just have to like look at this XML and let's get out of that. Let's see. Let's go through XML lint and format this, because that's like, why, who's using XML? This is 2021. That is not what I expected. Oh, wow. This is a special data set right here. Granted, let's go ahead and run an ETL job, right? Let's translate this to JSON and store it as JSON. Maybe that's the solution, but I don't want to store it twice. But I also don't want my client side, every client I build to process this data automatically. First thing I have to do, I have to translate XML to JSON. And that's, again, it's just like, depending on how big the data set is, depending on what's in it, like I don't necessarily want to do that for every one of my clients that has to read this data. But if the data is updated nightly or hourly or whatever, I don't want to run ETL jobs every time to now say, oh, I have to translate this on the data side to push it to JSON. I may not even have control of this data, right? Like this is a public data set, and New York City jobs is publicly available, and I can't do pre-processing to like change the format on it. Like this is a data dump from, you know, a third party essentially, and whose decision was it to make it XML? I don't know, but now we have to figure it out. So solution we've done in the past is, again, you can process the data as you send it. You can also process the data as you receive it. In the past, we've done this with having a web server, something that says like, okay, well, I stand up a server or a container or something, and I can, put some processing layer there. I can request that instance. Okay, now fetch me that other data and then process it and send it back. It's an option. We can also do it with something like Lambda, depending on how big the files are. If I can process my data before a Lambda times out, that's also a great option. And in the case of Lambda, I don't have to pay for things if I'm not actually processing the data, which I think is a great model. We can say, okay, well, let me just go ahead and request that data, pull it down, and the Lambda, is costs me nothing essentially, except for whatever the storage for the actual Lambda zip, I guess. But nothing is running, and unless I'm requesting it. But I do need an API gateway. I need some sort of extra network to expose that. If I'm exposing it, publicly or to my VPC, I might need, to handle credentials or some sort of IAM credentials for who can access it, because I can't just have like a public call for it. So there's these situations where like, okay, Lambda seems like it might make sense, and I do need to put a little more infrastructure around it to make it accessible. And actually just last week, we announced that you can now do this like natively. And so there's now this S3 object Lambda. So I can say, oh, I can actually have a Lambda that is tied to an S3 GET request. And the Lambda just fires. I don't have an API gateway. I don't have anything publicly exposed. I can go through my AWS accounts and I can request an endpoint. It automatically goes through a Lambda and sends that data back to me processed. Just like our let's send the data, I can now receive it in a way that makes sense for me to use it. All of my clients don't need XML libraries in them. They don't need whatever the other thing is. This helps with that processing before I get it. Also, I can use the Lambda to enrich the data from multiple sources. I can do my PII at that level. I can translate, like I can change things as they come down to me. If I have a S3 bucket full of images, I can put a watermark on all those images, or I can resize them on the fly. I don't need to store 20 different sizes of images in S3. I actually just, hey, if you need to resize the image, request this endpoint, give me in your request what size you want. I can use Python. I can resize that image and I can send it down to you in the perfect size for you every time. I don't care what size it is. I don't need to know, if it's for the website for, large tablets or a phone or a big screen, whatever it is. Like I can give you that file in the perfect format for you. So let's check it out. Like this seems like the perfect solution for what I wanted to do with this, with this data. It's XML. Like let's just first translate it to JSON, right? Like I don't care if the data formats are similar. Like I just want JSON data first. So I wrote up a quick Lambda here. And this hopefully is the only client that actually needs this XML to dict, right? I'm just going to translate the XML data, make it a dictionary, and I'm just going to put that into JSON. So in our Lambda, Lambda's don't run a server. They don't run a web server. That's serverless, right? Like it's not just a physical box server, but also like they don't run a Flask or Django. It's just like they process based on a function. It's functions as a service, not serverless. So we can take the server out of it, and now we have this data, and this is it. It's less than 30 lines. I'm going to take, there's some metadata that I get on this request based on, hey, I'm requesting that file, I'm requesting that object. Let's pull out some information so we can know what the context is for the, the file itself, the input S3 URL, so we know, okay, what am I going to get? And then where we're sending this data once we are done processing it. I'm going to go ahead and get that file. I'm going to decode it into an object. I'm going to turn it into a dictionary. I'm going to request it. And then I'm just writing it back. That's it. I didn't do anything work. I didn't do any additional work here. This is just, hey, we're going to turn this into JSON. That sounds reasonable. I don't know why. Oh, I know why. My file says it's deleted because my code window's in the wrong folder. Just a second. So what happens when you rename folders? Don't do it. So I don't know about everyone, but I'm not the best at Lambda's tooling. To me, one of the hardest things about learning a new framework or a new infrastructure or a new tool is actually learning the tooling around the thing. It's difficult to say, oh, well, like if I was learning React, like how is it, do I want to use NPM, NPX, Yarn? What is this Apollo thing? Like what, like there's a lot of things that go into like learning one piece. Is just learning that all the frameworks around it. SAM has great tooling. The serverless framework, there's the SAM CLI, there's all these things that work great for Lambda. I'm not super familiar with them and I don't keep up with them. I do a lot of my work in containers. Lambda added support for packaging my functions as containers and using those. To me, that was a huge win because all the extra tooling I actually didn't need. There's probably some benefits for me to learn some of this tooling, but in this case, I'm good. I can just use it as is. I can send a container to this endpoint and say, okay, use my container because that's actually, I understand Docker. So in this case, we're going to write a very simple Docker file. We're going to use one of the pre-existing Lambda runtimes. We're going to copy in our file that I just showed you for, okay, we're just going to translate this to JSON. We're going to run an install. And when the Lambda starts, we're going to run that Lambda handler function. That's all we need. That's the whole Docker file. So let's go ahead and build that. I'm going to cheat here and just reuse all my history because it's too early for me. I'm on the West Coast. I know it's 8:30 now and it's still early for me. So what I got here is I'm going to build this image. I'm going to call it PWC. It's the latest tag. I'm going to push that image to an ECR registry. That's where I store my container images. And I already set up a function. I have a function named PWC JSON. And so I'm just going to say, hey, that function, you need to use this container image. So I have a image URI is my endpoint. Go ahead and use that function for processing. So that function is set up as one of these Lambda objects, S3 object Lambdas. And so it's going to know, hey, if someone was requesting data based on that S3 bucket, it gives you another endpoint. It gives you an actual additional endpoint. So I can still request all the original data. Someone can have fun with their XML. I'm not breaking any other applications. On this other side, I can actually process that data just for me, just for my applications. If I want JSON, I have a JSON endpoint. And I can say, okay, this is the JSON processing endpoint. Great. Let's go ahead and build it and push it real fast. I already had some of the image built, so it cached a lot of it, but it automatically updated my function here. So now what I need to do is request my data through that JSON endpoint, the new Lambda endpoint that it exposed for me. Right now, the S3 copy command I don't think it's been updated yet, because again, this just came out last week. So you have to use a S3 API get object with my bucket, with my new endpoint that the Lambda exposed to me. If I go look at the Lambda itself, like I don't have API gateway, I don't have any additional infrastructure around this. Lambda is allowing me automatically just like, oh, you requested it from this endpoint. I can say what key I want to request. So I still have that same New York City jobs data. And in this case, I'm gonna write the file to disk and then cat it out and JQ it. All right. Let's go. Let's send that to LS2 just to doing the exact same thing on the data, but now that processing is happening in the Lambda. I'm not doing it locally. I don't have to pull down all the data. I am pulling down all the data right now, but I don't necessarily have to. All right. If I want to filter some of this data, I can do that in the Lambda itself. And this is processed before I get it. I requested data, S3 bucket or S3 object went to Lambda, did that processing and sent me back to JSON. This looks way better. Like I can do so much, like it's just easier for me. Like I don't need that XML layer. I don't need to always say like, oh, I got to document in the wiki, everyone that ever uses this data, please translate it to, XML or to JSON first. We can actually just say, hey, if you need this data in JSON format, go to this endpoint. We didn't store it twice. We didn't do anything to the data. This is just a JSON endpoint, exact same data. We did a little bit of processing. If I look at my Lambda like logs, I mean, it was like, I don't know, 250 milliseconds or something to process that. So it's still, again, keep it in chunks. I don't want petabytes of data streaming through this. There are timeouts. There are reasons that maybe you don't need to do this or don't want to do it this way. But if you have chunks that are indexed in an S3 bucket, this is great. So now I can actually use this data to make some decisions, right? Like around what it is that I'm trying to do in my company. Like that was the goal, right? Like we don't want to spend too much time on actually changing this data, but we actually need to get to a point where, okay, now we need to make decisions. And one of the decisions that, the company wanted to make was like, well, let's look at how many jobs are there. I could go through and just find all the IDs, but they also wanted to kind of like, oh, maybe we could like figure out what are the titles or levels that people are requesting, or what agencies are requesting this, requesting have the most openings, so that they can actually, maybe we're a hiring agency and we say, oh, well, actually, like if you go into, law, like there's a lot of opportunities right now in New York City. So let's look at that. So I have another Lambda that I made. Most of this is the same. All up front here, this is all the same. This mostly the same. The thing I'm doing different here is I want to minimize my fields. I don't actually want to download the entire file. I say, hey, Lambda, like actually just take out some of this data. Maybe that actually saves you money depending on how many times this was requested, depending on how big the file is or how many extra fields there are. Some of those fields were actually kind of big because they were paragraphs of like job descriptions. So it's like, I don't actually need all that data. So if I have a million job listings, all with job descriptions that I don't need, it's like, oh, well, actually, like, don't send that over the wire. I don't actually want that data. Just cut that out. The S3 Lambda is going to be really close to each other in data and not cost you anything to send data into the Lambda. So cool, like we can just pull that data out. And down here, here's my function for minimizing the fields. Ignore my debugging from yesterday. But here's the fields that I actually like. Let's say this is what we wanted to get. This is what the business said. These are the 4 fields that we actually want. This is what we're going to base all of our data learning dashboards, whatever the case. We have an internal website that focuses on this data. Great. That's all I need. I need to loop through this function, minimize some of those fields, and then just return that as rows. And so I'm returning a dictionary back up here, and my response body is what actually gets sent to me. That seems reasonable. Again, let's go ahead and I'm just going to reuse the same Lambda. Like I can reuse the same function. I can just replace the Lambda code, and I can say use. Now I don't necessarily, for the demo, I'm not going to set up 2 access points, but absolutely have them filtered however you want. You can have Lambdas for each type of endpoint for whatever processing you need. So I'm gonna do the exact same thing. I have a separate Docker file. I'm gonna build another container. And for me in the registry, I'm just gonna tag it with this filtered tag. So my registry actually has both functions in containers. I can switch them on the fly or whenever I wanted to, just by saying, okay, well, update your function code from this image to that image. And it's a pretty straightforward way to like, okay, the latest thing that I should be using is now going to be this filtered data. So when I look at that data, I don't have all those additional fields. I'm still getting JSON, and I'm getting the business fields, whatever decision we're trying to make. Sounds really reasonable to me. So, oh, and I'm using the same, using the exact same endpoint, right? I reuse the same function, so my endpoint hasn't changed. There's nothing about that is different for, right now we're using this bucket ARN. Eventually you'll actually have, you know, a S3 endpoint that you'll be able to use as well. But this is a great way to, again, stream just the pieces that I want, give me that data without everything in the format that I want. I don't need all of the clients now to understand this. There are absolute reasons to format this data client side. And I can say, okay, in the browser, we're going to send you 10 fields and now you do whatever you want with them. We can reuse that. But being able to find some common set of fields and reuse that over and over again is also super powerful. This is waiting for the Lambda, but saving all of this data transfer, local compute, everything was just happened through that Lambda service. So now I have the 4 fields that the business wanted. It's great. Like now I'm able to take that data and my data-driven decisions aren't necessarily just driving the bill. My data-driven decisions are driving whatever it is that my business wanted to do, because I'm not storing things twice. I'm not pulling down gigabytes of information. I'm not running ETL jobs. I'm running Lambda as needed, changing the data on the fly and being able to pull that just the pieces that I want back. And of course, like, you know, as an engineer at a company, like you solve this problem and then you're like, well, you know, like maybe I should actually look at this data a little more, because like maybe there's some of these remote jobs, maybe there's something that I would want to use out of this data. So you can also, you know, of course, still do client-side, you know, formatting on this. So here's one last, like I'm gonna actually run this client side. At this point, I'm just fetching the data that's formatted from that Lambda that we just made. I say, okay, all I want to do is display this in a table, right? So all I need to do is take that piece and then sort this data. Let's sort it by pay. Let's see who pays a lot and see if there's maybe a job that might be a good fit for me based on who's hiring, current open jobs in New York City based on pay. And so there is some formatting, makes perfect sense. Do this client side. Let's format that. Let's not changing keys, but just really just sorting it and displaying it in a human-friendly view. Oh. No less. What'd I do? I have Bodo installed. Okay. Make sure it's installed client side. I bet this is because I changed my folder name. No, if I'm in virtual environment, I don't know. We'll double check this in just a second. Stay with us. There was a report recently about Lambda startup time. And this is going to lag now because I'm downloading Bodo 3. There was a recent report about Lambda startup time, depending on your language, depending on how big the image is, what should you use for fast startup time? And containers didn't actually get affected by how big the container was. Most of all the zip files actually had an effect on, depending on how many libraries you have installed and how big that file is, that startup time might take longer. Doing a job like this, I'm not actually too worried about how fast it comes back to me. But if you are doing these Lambdas that need a faster response, like you're actually doing it from a web endpoint, containers had a larger startup time for some of the small zips. But once you got to a certain size, around like 15 megabytes on your zip, the container startup time was pretty much equal, and the container images didn't get affected by how big they were. So this container that I have, upstream container runtime, use those from the Lambda team. I am able to take that. The container image is like 600 megs. I don't really care. Like Bodo by itself is like 10. I don't really care because my startup time is consistent with the container. So pro tip, if you're looking at doing some Lambda. Come on, give me all those libraries. Sweet. Oh, and this formatting. Let's see. Can I get that table? There we go. I know it's tiny, but now like this is how this is the client side rendering that I want. This is the formatting that I actually needed, and I can see some hourly pay here. Okay, here we go. Now we're into like $46,000 for these. Like I could, okay, Office of Payroll. Oh, I got an inspector here. Consumer Affairs, $48,000. Hey, but we formatted this by pay. So let's just jump all the way down. All right, here we go. Chief Risk Officer, Executive, $265,000 a year. So that's the data decision, information that you can actually make personally. Use this information, from an S3 buckets. It's public data, but this is how you can use this information, make your own decisions, but you also can have your company make those decisions, format the data, and allow you to do a lot more with less by streaming the data and processing it during the stream. So that's all I have for you today. So I hope you enjoyed the talk.